Hey all, it's Altbeer here, and we're doing our weekly stream of the future badge design. So it looks like we're all running a little late this week, so the badge team has not yet joined, and I'm still getting set up, but we have some exciting stuff today. Hopefully, we can finalize our circuit design, test it out, and start working on the PCB workup to go to manufacturing. So let me start by getting KiCad open with the new circuit design because I did some work on that this week. And hopefully we have sound this week. It looks like it's working, unlike last time where it was muted. Um, let's get this going. There we go. All right, so did a lot of work on the circuit design, specifically on the NeoPixels. I went ahead and added a 47 ohm resistor to the data inlines. That was they recommended 75 ohm, but this dev board does some resistance outbound. So I think all we needed was the 47 ohm, but we're going to test that out. I mean, we've been running without any resistor so far, so I don't think there's going to be any issue with that. So yeah, we did that, and then on the RGB, or not RGB, the yellow red dual LEDs, I put a 47 ohm resistor on those as well. And then I built in all of the other LEDs. So we have our 4 blue LEDs and our 2 white LEDs. This will be for the lightning effect. And I put 47 ohm resistors on all of these. We'll have to test that out, see how it looks, see if we need to go higher. But the use of the 47 ohm, I wanted to try to use the same physical resistor for all of the badge. That way we didn't have multiple resistor types to work with. So that's kind of why I stuck with that. I don't know if it'll work or not. We'll test that out. And then we have our battery here. This is the 9-volt battery and our switch. So this is the same switch I used on last year's badge and a couple other badges. Just a simple 2-position switch. One's going to be off, the other will be on. On being it's going to provide 9 volts to the voltage in pin on the dev board. So that's where we led with that. And then we have our touch. I found a KiCad symbol for the touch. Actually, it was an ESD symbol that had like a line through it, like don't touch. So I just removed the line through it and made it a touch symbol. So this is going to represent our actual capacitive touch area. And so that's laid out there with the touch label. I did move the touch from this side to that side so that I could fit all of the dual LEDs on this side of the dev board. Then we have our 2 NeoPixel strings on here. And then we have all of our other LEDs here along with the touch. It's on that side. And the way I chose which pins to use and which pins not to use, I was looking at the pinouts, and for example, all of these pins, these 4 GPIO or 5 GPIO pins here, wait, 1, 2, 3, 4, these are output only. We or input only, I'm sorry. We can't use these for output, so they won't drive an LED because they're input only. And then these, the transmit and receive, these have to be in a certain state on boot up. Same with these 2 pins. They need to be in a certain state on boot up to prevent the dev board from booting up. Because if it's in a wrong state, it'll prevent the dev board from booting up. So I avoided those pins and just stuck with the pins I knew that were safe to use. And we actually used all of the safe to use pins with this design. So that's kind of cool that we actually used all the pins that we needed to. I haven't determined whether for the blue and the white if I'm going to do PWM in the code for that, but they are on pins that support PWM. And for those that don't know, that's pulse width modulation. It basically pretends to be an analog signal when really it's just a digital signal that's being pulsed to where there's so many cycles it's on, so many cycles it's off, and it makes it look like an analog signal to where you can dim the LEDs. So we knew we needed that for these. These, not sure if we need it in the code yet or not, but it's available if we do want to use it. So that's kind of where we're at with the design. And what I was going to try to do tonight was build this design out on the breadboard and see what we come up with, if it actually works the way I think it will. One point of concern that I'm wanting to test out is right now I have all of the NeoPixels, there's only 4 of them. I have them all being driven off of the 3-volt rail from the dev board. I don't have them being powered outside of that, like on its own power rail, direct from the battery. To do that with a 9-volt battery, I would have to do a step down to step down the voltage, because those guys can't take 9 volts directly. And if I could avoid doing that by just using the 3-volt rail, I wanted to. And since there were only 4 of them and their amperage usage is fairly low, I think it's doable. So that's what we're going to test out with this build, as well as with all of the LEDs built out. Does this actually allow us to use these NeoPixels directly off the 3-volt from the dev board? Or do they start having issues when everything else is drawing current as well? In which case we'll have to redo this design and provide it power from the battery, which we'll have to step down from 9 volts to I think 5.5 or 5.6 is the max that can take. All right, so that is the plan for tonight. I think that's all I needed to talk about with this guy. So let's go back to this design. So right now I have the 4 NeoPixels wired up almost exactly the way it is on the schematic. The piece that's missing is the data lines don't have the 47 ohm resistors, so we'll have to put those in. Then we have one of these 2 dual color LEDs, and I have 3 more here that we're going to add in. Then what we have for the blue LEDs, I got these cool little flat top LEDs. Let's see if that could show up on the camera. So instead of being a rounded top, the top is actually flat. So that way it's easy to identify this is the blue LED from the flat top. And then the 2 white LEDs are their traditional rounded top. So that'll be an easy way to identify the blue LED versus the white LED on the regular 2-pin LEDs. Let me just check in with my badge team before I go too much further. It doesn't look like any of them are joining right now, so we'll just proceed without them. All right, so first things first, I got a bunch of 47 ohm resistors. So let's work on fixing up these NeoPixels to where the data lines are protected by the resistor. So we have this white one is a data line. So instead of putting it direct onto the pin that it was on, I'm going to put it over 1 pin. And then we'll throw a resistor between those 2 positions. Kind of bend in. So there we go. All right, and then the blue line is also a data line. So we'll want to pull that and move it one over and do the same thing. All right, and then my yellow is a data line, and if we go back to the schematic for a second, we can see, if I zoom in, even the data line coming from the data out on the other NeoPixel has a resistor on data in for this one. I don't know if that's strictly necessary, but that is what the manufacturer prefers that you do. So we're going to stick with their documentation. All right, so put this one over one. Then we'll get a resistor there. Make sure the legs of the resistor are not shorting out. And there's this guy, last one for the NeoPixels. Pop that out. And I think that is ready to test if the NeoPixels like it, or if that has any kind of repercussions on their brightness or anything. I doubt it will. The 47 ohms is not very much resistance. All right, and we see that the NeoPixels are still working, and they're still just as bright as they were, so that's good. So now we've basically protected the data lines with that resistor from any kind of current overrun. That's all that resistor is really doing. All right, so now we need to look at our dual position LEDs, the yellow-red guys. So I think I'm going to start by just pulling this guy out, because I don't remember what resistor value that was. And let's take a look here. So we have two connectors going into D12, D13. So if we go back to our diagram and look at this, so D12 and 13, that's going to be 31A and B. So that's this guy. So that's the yellow and the red there. And then we want to put the resistor on the ground pin on the cathode. So I'm going to move this over just to keep them all together. So we have our pin for the cathode. We'll just put it one position over from there. And then let's get another black wire. And let's use this negative rail on this side for this ground. So I'm going to put this ground pin. Come on. All right, so that's in the ground pin. And I'm going to put this on this negative rail. We'll put it down here. That way I can just put the resistor. Actually, I don't even need this jumper then, because what I can do is just put the resistor from the negative common cathode to the negative rail using this resistor. That'll make that connection. All right, once again, 47 ohm resistor. All right, so now we want to get some of these other guys in there. Let me just take a look at this guy. All right, so according to our diagram, oh, and I had the diagram up the whole time, so you didn't see me moving stuff around. Great. So the yellow is pin 1. That is the longer of the two outside pins. So the shorter one is pin 2, which is B. So it looks like I want yellow to be on A and red to be on B. And that was correct. So let me turn that diagram off and actually show you what I did here. So basically I moved the ground wire to this negative rail, removed the jumper that I had there, and then replaced it to where the common cathode is now using a resistor to get to the negative rail. And now I'm going to put in, let me just look again, yeah, that's the short pin goes to the right. All right. So now we're going to do another one of these guys next to him. And short pin to the right, good. Okay, and so now we're going to need some jumpers to do the next one. So we're going to assume this is our second guy, which is going to use data pins 14 and 27, the next two data pins up. I'm going to get some jumper wires to use for that. Now, let me see if I can find some short ones. Yeah, these two will work. All right, so yeah, 14 and 27. Let's actually flip this around so we can see the numbers. So yeah, 14 and 27 are the next two pins in line. So I'm just going to put these jumpers right there. And then we'll jump these down. To the positive, the anode connectors on this LED. 1427, and then we'll do another 47 ohm resistor to the negative rail. The next LED ready. Come on. Go in there. There you go. And we'll get two more of these guys. And so that'll be the next two pins up. And I should probably move this touch pin since we're going to reprogram him. Okay, get another resistor to go to the negative. And once we get these four on there, we'll actually write some code to work with them. the 4th. 2 more jumper wires. And so those last 2 pins are 32, 33. Put those on the anodes. And let's get a resistor for the cathode. Alright, looks like I already lost an LED by having it stick to my arm. So, flashlight app to the rescue. Is there an LED down there? There it is. Alright. Yes, we'll need you later. Looks like somebody is chatting. Yes, things are going well. We're moving along with our design. All right, so now we have the 4 dual position LEDs, and we know we want to move the touch pin as well. Let's look at the schematic again and see where the touch pin needs to go. So he's going to be on GPIO 4, which is touch 0. So let's connect him up over there. And then we'll write some code to work with these guys. So let's see. GPIO 4, there we go. All right, so now we have our 4 2-color LEDs in place. And now we need to write some code. So let's get the Arduino code up. Let's see, code. There you are. And it's thinking about launching. I think I can. All right, so here is our code. So we need to redefine some pins and define some new pins. So our NeoPixel pins stayed the same. Let's pull this over to this side. So our LED 01 pin, let's see. I don't think that changed because we had it on 2728. Oh wait, 1213, where's that? Oh yeah, 12 and 13, 27, 28 are the pins, 12 and 13 are the GPIO names. So we have 12 and 13 are 31A, 31B, which corresponds to LED 1, which we'll rename this in the code later. But we have 3 more to add here. So let's get this going. guess I didn't need that. So LED 2 is going to be on 14 and 27. And the way I numbered these were 1 and 2 for these two as if they were two separate LEDs. So we'll just stick with that. We'll say it's 3 and 4. And that is 14 and 27. Yeah, we'll pretty it up with comments later. So we got 3, 4, and now we have 5 and 6 are going to be our next two, and they're going to be 26, 25. So 7 and 8 will be 33, 32. Now our touch pin is no longer 32. Instead, our touch pin is going to be 4. Which is touch 0. Okay, so we have channels and frequencies. We can mess with that later. Because for right now, I just want to test that they're working. Yeah, I don't care about any of that. Yeah, because we have our touch pin. Threshold value stays the same. All right, so in our loop here, I think what we'll do is where we're doing these writes, I'll probably need to define these LED pins. Yeah, I guess I could use the same channel for all of them. Let's just do that and make them all do the same thing. Because then when I do the channel writes, it will just make all the LEDs do the same thing. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so we're assigning our LED pins to the different channels, and we're using the same two channels. And that should mean we don't have to do anything here because we're doing a channel write. Should. Let's see if this works. All right, so we'll save you and check you for errors. And then we'll hook you up. screen. All right, good. All right, let's push this new code and see if it lights up the other 3 LEDs. And look at that. So all of the LEDs are sharing the PWI channels, so they're all doing exactly the same thing since I'm doing channel writes. So they're going between yellow and red. I know it's hard to see on the screen, but yeah, it proves out that all of these are wired properly and they're working. Okay, so now that that's done, and that was really the main concern there, we just need to pin up some other LEDs. And yeah, so let's figure that out. I need to get some more 47 ohm resistors though, because I'm about out. All right. So this will be the next group. It looks like I have 2 people viewing. Thank you for viewing. Feel free to say hi. I am trying to monitor the chats in between what I'm doing here. But I need to dig for some resistors. All right. Alright, let me just check in on the badge team, see if anyone joined. I don't think so. Nope, not yet. Alright, so let us unplug you for now. And let's verify our LEDs. So I have 4 blue ones, or actually there's 4 blue ones. That nice flat head is nice to identify them with. And we have our 2 white ones. And I need some resistors. Oops. Let me share the proper screen. There we go. So we got our 4 blue. We have our 2 white. And we got some resistors. I'm going to need some jumpers. So if I look at where these are plugging in, they're all on that side. So I'm going to need some jumpers on that side. Let's see, is this 6? 1, 2, 3, 4, 5, 6. I'll pull this extra one off. All right, so let's see if we can just wire this up. So it looks like I need GPIO 23. Let's actually spin this around so we can look at it from this side. All right. 23 and 22 next to him. All right, those 2 are in. And then we're going to need 21, which is going to be next to this guy. All right, and then we need the 3 in between the touch and the NeoPixels. All right, so there's 1. 2, 3. All right, so we have those jumpers in. Try to move this white guy out of my way. See if I can jump under this stuff. Okay. And we'll just pick some places along here to put them, and then we'll plug the LEDs in. Come on. All right, let me just consult my diagram here. Where'd you go? Looks like Eganzola or Eganzal, you are a fan of the homecoming badge. Thank you for that. And hopefully this one will be just as cool once we get past this electronics stuff. The artwork is definitely coming along. All right, so here's the blue guys, and it looks like if you recall from the way LEDs, the normal LEDs work, the long leg is usually the positive or the anode, and the short leg is the negative that we are going to bring to ground or the cathode. So let me just consult my diagram here for the pinout, and we can see we have the way I wired these up. LED 1, 2, 3, 4, 5, and 6 are all kind of in order using that wire layout that I did. So if we come over here, looks like LED 1, 2, 3, and 4 are blue LEDs, and 5 and 6 are the white ones. So that's what we'll wire these up with. All right, and so that means we're going to start with the blue on this side, and we're going to put the positive leg on the GPIO port. That's the long leg on the GPIO port, and the short leg we're going to put on this blank section in between the two jumpers. And then we'll do that for each of these blue guys. Come on, get in there. Why won't you go in? There you go. And then the last two we'll do the white ones, and then we'll plug in all of those resistors that I got out from the cathode leg of the LED over to that negative rail. But what we're going to have to do, because we're further up on the breadboard, that negative rail on these full-size breadboards only goes halfway up. So we'll have to do a jumper to get ground over to it. All right, so now we got our 4 blue and our 2 white. And then we'll do some resistors to jump from the negative to the cathode to the negative rail. for all of these guys. And for the code, we're just gonna, because we just want to see them light up. I don't care if they blink or do whatever. I'm just gonna make them go high, make them turn on and stay on the whole time. Yeah. Come on. Three down, three to go. Whenever you're plugging stuff into a breadboard like this, especially with components that have very long legs like these resistors or the LEDs, you want to take care to make sure you don't have any shorts where the legs of the components are not touching each other or shorting anything out. And I think that looks good. Alright, so before we plug this in, let's get some code to drive this. So let's come back to, oops. Well, we come back to this display to where we know 1, 2, 3, and 4 are blue, 5 and 6 are white, and so we know what our pins are here that we need. So now we will define these, and yeah, this test code, I've totally screwed up the LED numbering. It does not match the layout at all. But what we're going to do is just call this, like, I'll put B01, or actually just B1 for this guy. And that is 23. B2 will be 14, no, 22. B3, B21. So B4, B5, let's call it W for white, 1. It'll be 17. And white 2. Will be 16. Alright, so we got our pins defined. Now, let me just Google real quick. I don't think I have to set anything special for those pins. Probably have to define the pin as an output, because I don't think I had to do that with the other ones because I was adding them to a channel. So I'll do pin mode, and then one. Output. So that should set them all as outputs. And then the simplest way for us to just do this, just turn them on and leave them on, is probably digital right. Okay, and then let's get my pin. And we'll set that to high. Blue 2, blue 3, blue 4, white 1, white 2. All right. So very simple. It's just going to set these pins to output pins, and it's going to set their value to high, which should just turn them on and leave them on. So I don't care about flashing them or doing anything fancy. I'm just checking, did the pinout work? Are they actually displaying? All right. We'll save that. We'll do a quick verify, make sure I didn't screw up and leave off any semicolons or crap. All right, so it looks good. I was just double checking my actual layout, and let me switch to this view so we can see if they all turn on. There we go. All right, let's hook this up. All right, they're not lighting up yet because I haven't pushed this code yet. And let's push the code and see if they light up. Compiling, pushing. Well, they didn't light up. Oh, you know why? I mentioned it, and then I didn't do it. The negative rail. We have to jumper it from this side to this side. Look at that. Now it's a complete circuit with the negative. And I don't know if we can see the colors, but you can see blue, we got white, we got the NeoPixels, we got the dual colors, and it's all working. So last thing to check is we know this is working off of PC power with the USB. Actually, before I do anything else, let me make sure, open up a serial monitor. Make sure the touch is still working. Yep, touched. Every time I touch it says touched. Okay. So now the next test, the code's been loaded to it. We want to see how it's going to work with a 9-volt battery. Well, I happen to have a bench power supply here that I can configure for 9 volts. Let's see. Set for 3. Let's set it for 9 volts. And then we will put that on the voltage in and the ground. Got too many wires here, I can't see. Okay, there we go. And I'm going to have to, because it needs to be close to that side for the power to reach. So what I did was I have these 2 wires that go to my bench power supply. The red wire is going into the voltage in on the dev board. The black wire is going to the ground. It's set for 9 volts, and I'm going to turn it on. Alright, and so I turned it on and it's all working, and I don't see any problem with the NeoPixels running off the 3-volt rail with 9 volts. And let's look at what our amperage is, 0.15, which is not bad. Looks like it's 1.4 watts of power. And so I think that's going to work for us. I think we proved out our circuit tonight, that this is the circuit that will work for what we want to do with the badge. It's running all of the LEDs at full power. Yeah, this will do well. Let me try it at a lower voltage, because the 9-volt batteries, as they start to die, they actually provide lower voltage. So let's dial the voltage down in this guy, and we'll try 8 volts. Yeah, it's still looking good at 8 volts. Everything's working with the 8 volts. I don't know how far down a 9-volt battery goes, but we can power this off and try 7. See what that looks like. Yeah, it's still looking good. All right, well, I think that was our plan for tonight, was to prove out that the circuit works. The circuit being this one here that will be on our GitHub soon. So this has our touch. It has, we didn't wire in the switch or the battery, but that could easily be done. It has our 4 NeoPixels driven off the 3-volt rail. Each of them have capacitors, which are on this breadboard. It has the 47 ohm resistors on the data lines. It has our dual color LEDs with the 47 ohm resistors. And it has our normal 3mm LEDs for blue and white. All of that is working perfect. We can work on the code to make the LEDs do different things, but electrically this is a sound circuit. And so now we can proceed with the next steps, which will be turning this into the PCB layer. So our next stream will go into the actual PCB design of this, and I think we might actually do it early next week, possibly. I'm thinking about a Tuesday and Thursday stream next week, just to get a lot done, because we do have a lot to do. We want to get this prototype off to manufacturing, and then get the actual circuit components priced out for ordering, and then get our Kickstarter going, which I keep saying Kickstarter. I don't think we've determined if we're going to use actual Kickstarter or one of the other crowdfunding platforms, but it will be some type of crowdfunding or something along those lines to allow people to purchase the badges early for pickup in Vegas. So that is where we're at. This was a good test, and yeah, so I hope you guys tune in for the next session. Worst case, it'll be Thursday. Definitely do it Thursday. We might also have a Tuesday night stream, just depending. So yeah, thank you for everyone that is watching. For those of you that are following along with our Badge Life diaries here as we create this stuff, we appreciate all the support from the community on this. So yeah, and hopefully we'll see you next time. So this is Altbeer, and I'll talk to you all later. Thanks.